Okay, now members, we are going to see a new topic, and this topic is called friction. I think everyone, here you have heard about frictions. For example, when you get your hands and you try to, because they are not so smooth, so if you try to rub them, so you are going to receive some heat. So that heat is being caused because of friction. Friction occurs always between two or more surfaces in contact. So here you can't have friction because there is no contact. So, but if I put a contact like this and then I try to move the hands, so then that's when I cause frictions. So, this is a force that opposes the relative motion between two rough bodies in contact. It occurs when there is contact. Smooth surfaces in contact have no friction. Smooth we mean like you see when they put oil. So there we say this is smooth because there is not going to be friction because of the other oil removes the roughness of the surfaces. So laws of frictions, these are fundamental laws that describe the behavior of friction force. Namely, friction force only exists when one body slides or attempts to slide over one another. So you see, when I have my hands like this, when I try to slide or attempt, that's when friction will occur. So try to slide one over the other. Friction force always opposes the tendency of one body to slide over the other. So if I want to slide like this, then friction force is going to be going the other side. So when this one is going like this, then for it is to be going like that because it's always opposing the motion. Magnitude of friction force may vary or it's being coefficient to prevent motion until it reaches a maximum value or the limiting value given by mu r. So it's going to vary as we are going to see this diagram. So it's going to vary, but it's going to reach at a point when it's no longer varying, and that point we call it the maximum value or what we call the limiting value. For mu r, this one is called the mu r, it's given by mu r, where mu, the limiting value, is given by mu r, where mu is the coefficient of friction, which basically the roughness of the two surfaces in contact. Then R is the normal reaction of the surface as we saw. For mu, R, mu is the measure of roughness of two surfaces in contact and differs from different pairs of surfaces. So the mu, the roughness of my hands, is going to be different from the roughness between this ruler and then the box. So that mu differs from the pairs, depends on the pairs you are having. When a body slides over another, the frictional force between them equals the limiting value mu r. As long as the moment is motion implies that now the frictional force has reached the maximum. 3 and 4 is that the implication of 3 and 4 is that friction force F obeys the relation that it's always equal to this. When it's raised, there is no motion. There is motion only if F is equal to mu r. So it means that always friction force, the maximum is when you have this. Note, friction force always occur parallel to the surfaces in contact and always opposite to the direction of motion. So when they are sliding it over like this, then the friction force is going to be opposite to the direction of motion. Consider body M resting on a surface, a rough surface pulled by a horizontal force P with a friction force F. Of course, now I'm going to give you this. I'm going to use this as my example. So now I'm considering the ruler to be the horizontal surface, and now I'm pulling. There is a force. So that now, if I pull this box like this, now that's what we are considering. So there is a force pulling it the other direction. It means that now friction is going to occur the opposite direction. So if motion is in this direction here, as you see, then friction force is going to be opposite to this. But now, when you see motion, it means that now friction force has reached its maximum value, which is mu r, or the limiting value, when it can no longer prevent the motion, as you can see here. P will gradually increase. So this force here, F is the frictional force, this is the pull force, this is the weight, and then this is the reaction. Remember, there's always a reaction between the body, the two bodies. So the reaction between this body and then the horizontal surface. So this P will gradually increase from 0, and F will also increase from 0 in an attempt to prevent motion. Now, this is what I'm going to do it at once. When motion begins, it means that F has reached the maximum or the limiting value mu, and it cannot increase anymore and to remain constant, i.e. F will equal this or whatever increase in P. Now, at this point it means when P is 0, this pull force, because it's going to increase, but because we're just applying. When it's 0, even the frictional force is 0, because there is not any attempt of motion, or there is not any attempt to slide, so it's 0. But when you increase the force gradually at this point, there is a point when we are going to be, when that force is almost enough to make this body move. So when this point, when we reach this point, when this force is at this point, it means that now friction force will be at its maximum. Now, not like this. When I have this body and then I'm trying to pull it, so that I'm gradually starting, you see, I'm applying the force gradually. The force is still now 0. As it's there, now there, friction is already in place. But now it's still greater than the force we're applying. So that's when the friction, now it's that the friction force and the force I'm applying, they are equal. So neither the body will move, so the body is going to remain at rest. But when you see that this, now their friction force is at its maximum, but the body is still at rest. But as the moment you start, this body is moving like this, it means that now the force I'm applying has exceeded the frictional force, and so the body will move. So there we see that friction is at its maximum mu r. So that's what we have been seeing there. When P is below this, F is going to be less than this, and so F is going to be equal to R, and the body remain at rest. When P is equal to this, F is equal to R, body is in limiting equilibrium. So there it's about to move. It has not moved yet, but it's about to move. And when P is greater than P naught, when this P is greater than P naught, it means that now there the friction force has its maximum and can no longer prevent motion, and so the body will move, and so it shall be having motion for the accelerate. As long as the body is accelerating, it means that friction force, if it's there in a rough surface or between two rough surfaces, it means that the friction force has reached its maximum. So as long as it's that the body is moving or anything is in motion, if you see my hands are moving, it means that the friction force between them is at its maximum or at the limiting value. So that's it. Now we are going to see the arm of friction and the next lesson. So please don't forget to subscribe to the channel. I wish you well.